type 1 and type 2 error. This is for chapter 21 in our book. We actually used the example from the astrologist, and they're trying to basically match up someone's personality profile with their birth date and their horoscope. If someone were just guessing, if the HO, where we assume that there is no effect present, that they would get, they have 1 out of 3 chances of guessing correctly. The alternative is that they believe that they can do a much better job than just guessing. So we assume, or we write in that my P is going to be more than 1/3. Okay, our alpha level of this problem is going to be 0.05, and it's an upper tail test, a one-tail test. In this case, that means our alpha level or our significance level, which is the same thing as our type 1 error, is going to be 0.05 or just 5%. Which means that if I actually reject the null, however it was true, then I make a type 1 error approximately 5% of my time. On the other side, if I fail to reject the null, then basically I've provided very little evidence to suggest that they have a power, so we would simply conclude that they're simply just guessing. My null hypothesis holds to be that my evidence supports that idea. If we do in fact reject the null, then we would have provided strong evidence, or at least some evidence, to give the idea that they do have some type of ability to do better than simply guess. They're better than the average Joe. All right, part A. The first thing we want to do is we really would like to ask the question, what proportion of correct answers would we like to say that beyond this number we're going to believe that they do have some type of ability to guess? Okay, now this number isn't arbitrary. We don't get to just make it up. It comes from knowing what my alpha levels are. My alpha level, if I look at my curve down here, this is 5% of the area. Okay, that is a specific number in terms of a z-score and even an original proportion from my questions. How many did they get right, and what proportion of the questions do they need to get right before it becomes where I would reject it? And so we can use our z-score formula and work backwards to find that. To find the correct z-score, I need to use my inverse norm. If I do that, inverse norm of 0.95, I'll get 1.645. Because it's a one-tail test, I can just type in the bottom area. If I work backwards and I solve this equation for p hat, then this is what I get. I get 0.405. So roughly, if they were to be able to guess 40.5% of the questions correctly, then I would reject my null, indicating that they may in fact have some type of predictive power. If they make less than that, then I fail to reject my null, and I still conclude that my evidence does not support anything about some kind of power that they have over predicting from the stars. Let's look at our curve. Alright, when you look at this curve, really you have the rejection region over here that's shaded, and you have the region, but we're willing to accept any variation within this white part as natural variation. Okay, this is the 1/3 of the questions here, and so you have 95% of the curve down here and 5% above it, indicating my alpha level of 0.05. Now, I can reject a null based on 3 things. Now, we normally are only going to use one, usually a p-value that we get from a significance test. The first thing I can look at is a z-score. This green line is represented by the z-score of 1.645. So if we were to simply find the z-score for a certain value that we got a p-hat, then if the z-score happens to be larger than this one, meaning it's going to be out past that green line to the right of it, under the part of the curve that's rejection, I could also go on an actual p-hat, an actual proportion from the actual sample. In other words, if I know that more than 40.5% were correctly guessed, then that proportion falls also in this shaded region, which means I'm going to end up having to reject the null as well. And of course, you can go down here. We see our p-value of 0.0495, which rounds to 0.05. A p-value, and which is basically what we decided to make our choices on from the beginning. We hopefully you feel comfortable about what to do with that. Type 2 error. Let's talk about type 2. If I'm going to be able to create a type 2 error, I have to have an alternate suggestion for what my P should be. And in this case, the Council for Geocosmic Research actually claims that they have a probability of 0.5 or higher. They should be getting half of them correct instead of just 1/3. So if that's true, we'll need to be able to figure out what's the chances of that happening. And so what values of the sample proportion am I going to actually make a type 2 error? Okay? In other words, and we've actually already found that value. That's if I have less than 0.405, if it falls in, if my proportion, if they get like 40% or 35% correct, then I would fail to reject my null based on my original significance test. Right? But if this is the true value, then I'm rejecting a false null. We believe it to be 0.3 or 0.33, but when they say it's 0.5, so the question is, if it is 0.5, what's the probability that I'm going to detect that this really is the true mean? Okay, and to do that, we have to find a few things. Before we go there, when the null is false, a type 2 error will occur when I fail to reject it. So in order for me to find a type 2 error, the null has to be false. And then I say, oh, I believe this incorrect null, that's a type 2 error. From the diagram, if I get a p hat or a z-score inside this region, then I would fail to reject the null. Right? Now, in order to find the probability of a type 2 error, I need to go in and recalculate a few of my statistics. The first thing we need to recalculate is the z-score. Z-scores are based on means and standard deviations. I want to know what is the new z-score for 0.405. Okay, so you can see here this p hat should be 0.405 right there. That's a mistake. That's a typo. But 0.405 right here, and plug all that in, find out your new z-score. That turns out to be negative 2.047. Okay, this, if you simplify the standard deviation, you should get this. Right? If I look at my curve and the area under the curve less than the p hat, now why did I choose less than? I'll get to that in just a second. Less than the p hat of 0.405 when the null is in fact 0.5. You can see this curve is centered on 0.5 and that line is 0.405. Then the area under that black shaded part is 2%. And that's that is my type 2 error. Here's the explanation of all that. Here's my curves labeled and sitting on top of each other. The x-axis you see down here, 0.33, 0.405, and 0.5 are standard. That's like one solid x-axis. Okay, the green line is my division of the original acceptable region here and the rejection region down in here. So the blue part is my alpha. This is my 5% from the original curve. This is my type 1 error. Alright, if I put the curve up here from the last calculation, if I put that on top of that and I match up the 0.405 on both sides, then what falls into the original acceptable region is my type 2 error. Well, the area underneath this curve, which was here, is basically 2%. Okay, this 2% is my type 2 error. I got an email. Alright, and so the last thing we talk about is power. Power, in order to calculate power, it's fairly easy to calculate power. You have to have type 2 error. Say 1 minus your type 2 error, and that gives you 0.98. Now, how do we interpret all of these numbers? 2%, 5%, and basically 98%. Well, type 1 error, we will reject the null when it is true 5% of the time. This is based on your alpha level. Okay, a type 2 error. We will fail to reject the null 2% of the time if the null is false, given that your actual null is 0.5 instead of 0.3. Remember, your type 2 error is based on a suggestion of an alternate mean rather than the assumed given mean at the beginning. And then your power, here's kind of a conclusion statement. If astrologers truly have some predictive power, in this case they suggested it was 0.5 or greater, then we're going to be able to detect that mean or more 98% of the time. And so that's our ability to basically, if I reject the null, I'm going to make a correct decision 98% of the time if I have a alternate mean of 0.5 or more. Now if I change my 0.5, my alternate p-value or proportion, then it's going to change my power. It's going to change my beta. Okay, it's going to change things because my curve begins to change. So when you find power in type 2 error, it is directly linked to the suggested value for your new proportion of your population. Make sure that you check out, I'm going to put this worksheet on the web as well. It probably won't print that great. However, I'll do my best, and you can, if you have a, if I can spell sample, S-A-M-P-L-E, if you have the Adobe's Acrobat, you'll be able to read it on your screen fairly well, probably like what you see here. If you have any questions, send me an email. See you tomorrow.